You can hear me?
Hi.
Yeah, you can hear me now?
Yeah.
Okay. Is it cold there?
Yeah.
Is it
It's almost
raining? Is it raining?
no.
Okay. Winter has not started, right?
No, it's fall.
Okay. Right. I saw the revision pack also.
Mm-hmm.
It's not difficult.
Yeah. The beginning part of it's fine, but my teacher told us yesterday that there's gonna be 7 questions on the test, and most of it's like a lot of the questions are focused on graphs, like your velocity versus time, position versus time, acceleration versus time. Yeah, I looked over them.
So,
So I did 1 and 2, or I did number 2 by myself. Our teacher helped us with 1 on Friday. And I got 2 correct, but then I was struggling with 3.
you can see the screen now.
Yeah.
So first two you got, is it?
Number 3.
Yeah. So what is the difficulty in this one? First thing is you have to draw a diagram.
Yeah.
So did you draw a diagram like this?
Yes.
So the information, I have chosen my x-axis and y-axis like this, and the origin is here. You can see my pointer.
Yeah.
This is the origin. Okay.
Okay.
So initial velocity is how much? 30.
Yes.
And the angle
Wait,
is 20.
how did you get? Oh, okay, it says. But isn't
Yeah.
it 30 meters for a 20-degree angle?
Yes.
Okay, and that's for your horizontal.
No, I just put 30 meters per second and I put the direction.
Okay.
I have not taken the components under.
Okay.
Just the data in the question,
Mm-hmm.
and 40 meters is the range
Yeah.
or whatever the distance of the goalpost, and h is this height. Okay. So at 40, okay. If,
Wait, where's your 3 meters?
see this h, if it is equal to 3, then we
Mm-hmm.
just clear this goalpost. Okay.
Mm-hmm.
This h should be equal to 3 if it is just clearing. If it is more than 3, then it will clear comfortably.
Mm-hmm.
If it is less than 3, it will go underneath it. So clearing means going underneath or going above. It should go above, right? If it's clearing.
Yeah.
Okay. So basically, let it be this h at this distance of 40 meters, and we have to check whether h is, how is it related to 3? Is it equal to, less than, or greater than?
Okay.
Get the idea, right?
Yes.
Okay. The first thing is you have to draw this diagram, and whatever data is given in the question, all these things should be put in the figure so that you will be clear.
Okay.
Right. So just don't look at the solution. Can you just try now?
Um, okay. So first I should find the time, right?
Yes.
Okay.
How are you finding the time?
Wait. First I should use sine or cosine to figure out what the initial velocity is.
Yeah, do the number calculation in the end. Don't waste your time in calculating the numbers. Uh, yeah, of course, x comma v naught x is 30 cos 20.
Yeah, so 30 and then I'm
Don't
trying to
do,
find x. Okay. So,
do the calculation in the end. Don't do it now.
okay.
For finding t, what equation you're using?
Um, I'm going to be using 1/2 AT squared plus VOT plus X sub 0 or Y sub 0.
Okay, what about no, in that you, how will you find t? There should be only one variable, no?
Yeah, T squared. Oh, then I would use X equals X sub 0 plus VT.
Yeah.
Okay. Okay. Is
Just
X
see
sub 0 0?
see, before starting, you just see which motion is easy to tackle first. X motion is uniform velocity motion, right?
Yeah.
So x equal to v naught t plus x naught. That will be simple because x naught is how much?
0?
Yeah. And what
Okay,
about
and
v naught
then
x?
um 28.19
Yeah, I said do the
times.
calculation in the end. Okay. You just have to say
Okay.
30 cos 20. Do the number crunching in the end.
Yeah, that's what I got. I got
Yeah, yeah.
cosine of 20 times 30.
Yeah, yeah. But I keep telling do the number collection in the end.
Okay, yeah, I'll do that.
And what is x?
40.
Yeah.
Okay, so then I got time is gonna be 1.4 s per seconds.
So that is the time to go from here to this much height.
Yeah.
Okay.
Okay. And then from here, hold on, let me finish writing this down. Okay. And then from here, since I know my time, I would use 1/2 AT squared plus V sub VOT plus Y sub 0 is equal to Y.
Yeah, y motion.
So I don't know Y. Y is a question mark. Y sub 0 is 0.
Yeah.
Okay. Um,
I'll
okay.
just come. Hold on.
Okay. Yeah, I can finish solving this.
Huh?
Wait, is Y sub 0 0?
Yeah, because the origin I've chosen here, no? So that is
Yeah.
the point. So why
Okay, and then VO is 10.3.
30 sine 20?
Yeah. No, 20. Sine 20 times 30.
Yeah.
Okay. So VOT is 10.3.
So what is the value of h?
Wait 1 second, I'm almost done. Okay, I got height is 4.8.
Yeah. So it's clearing it's going above the horizontal bar, right?
Yes, so it will clear the bar by 4.8 minus by 1.8 meters, right?
Yeah.
It's asking how much.
Yeah. So my steps are clear?
Yes.
Okay.
I think I'm good now with horizontal or with asymmetrical and symmetrical.
You know why this is asymmetrical?
Yeah, because the time is different.
No, see, from the maximum height point, here it is getting truncated, no?
What do you mean by that?
This is the maximum height point, right?
Yes.
So this part and this part are not same, right?
Yes.
Okay, this part is getting stopped at h. Suppose if
Yeah.
I continued and hit the ground, then it will become symmetrical.
Mm-hmm.
Okay, but we are analyzing only up to this one.
Okay.
Right. So what about 2 and 1? There is no doubt, is it?
Wait 1 second. Let me go back.
Yes.
One,
Actually,
one,
actually,
no.
yeah,
No. Two is fine.
you follow the steps, right?
Yeah. I drew my
Yeah.
picture first.
Yeah.
Yeah.
See here in this, I'm launching from here, so that's why I choose the x origin as here. Suppose you
Mm-hmm.
launch from this edge, okay, then I've chosen my y-axis like this.
Mm-hmm.
So wherever the point is being chosen, that should correspond to x equal to 0.
Okay.
So y naught here is 25
Yes.
because I'm choosing the origin as here.
Is y not your height?
See, that all depends on where you choose your origin. The origin I'm chosen here, right?
Yeah.
And
A
the
zero?
initial position is here.
Mm-hmm.
So this much distance is y naught.
Okay.
That is the height of the building,
Okay.
right? So
Yeah.
you have to understand the problem fully. I mean,
Okay.
you should not just say height of the building is always y naught. It depends on where you're choosing the origin.
Okay.
Okay. So in another problem, you might have chosen origin in some other convenient way. So in that case, it will be different.
Okay.
Okay. So you have to look at the problem carefully.
Okay.
So worksheet next 16.
Let me take a look.
17 is
Yeah,
done.
I'm good. I'm good with that one.
17 is okay.
17, yes.
Okay. It's a revision pack, right?
Yeah. It wasn't that bad, the review packet.
It was simple only. So which one are you discussing revision pack?
1 second, let me open it. Number 2 first.
Have they given the answer key?
Yeah.
Number 2 you already done in the regular worksheet.
In the regular worksheet?
Yeah, something similar, right?
Yeah.
Yeah, how do you do it?
You just draw it.
Yeah, so in drawing this graph, x versus t, we position, velocity and acceleration, right? So which is the easiest graph to draw first?
Position,
No.
acceleration.
Yeah. Okay, so what is the value of acceleration in this part?
Negative,
Value?
negative 9.8.
No. 9.8 is freely falling. This again along an inclined plane, right? So
I don't know.
suppose this angle is theta,
Mm-hmm.
then the component of g along this thing will be g sine theta. Okay, and
Okay.
suppose if this thing is some other angle, say beta, then again the acceleration will be downwards only because gravity will always pull it down.
Mm-hmm.
G sine beta.
Okay.
Okay, so the word, okay, approximately it looks as if theta and beta are approximately same. So
So
initially,
draw a straight line down.
initially the acceleration is suppose you take the upward as positive.
Mm-hmm.
Initially the acceleration is negative. So this is g sine theta and this is
Mm-hmm.
g sine beta. This value. Oh, in between in between there is one part,
Like
right?
at the origin at T.
So in between, what is the acceleration here?
Like 0?
Yeah, but Earth's gravity is there, no?
Yeah.
So is it G?
Yes.
Actually, it is not G because it's not. See here, the rigid surface is there, no? So you don't allow it to go down. Suppose if it
Okay.
is falling down freely, then it will be G. This rigid surface is going to stop it, so that
Mm-hmm.
G effect is cancelled. So it's zero only.
Okay, so I would draw a line there at 0.
Yeah. Let me call this time as T1 and this time as T2. And T1 is the time where it reaches here, and T2 is the time where it comes here. So here in between it will be zero.
Okay. My teacher drew it the other way around.
Then you see here I've used this convention as upward is positive, right?
Mm-hmm.
Hold on. No, see while coming down, its velocity is increasing. So
Okay.
when the velocity increasing, the acceleration is positive. So this thing should go up. This part velocity is increasing, right? So acceleration is
Yeah.
positive then. God.
Wait, why is acceleration oh,
Positive acceleration means velocity will increase.
but it's going down.
That does not matter, right? You just have to think the velocity. Acceleration is dv by dt.
Okay.
So whether v is increasing with time. Right. Yeah. See, in another sense also it's true because velocity is increasing, but it's becoming more and more negative.
Mm-hmm.
No, that's not a big point. Okay. The understanding should be clear. Velocity is in other words, what I should, if you're strict, then I should add this information. I'm taking downward direction as positive.
Why? Because that's the desired direction.
No. It's a choice. It's based on convenience.
Okay.
No. Here the acceleration, it's always downwards. So there also it should be positive then. Okay, this doesn't make sense here. This direction is for okay, acceleration positive or negative is decided by velocity is increasing or decreasing. Okay, here the magnitude of velocity, it's increasing for the first
Mm-hmm.
part, and there the magnitude of the velocity is decreasing for the second part. It's not a big thing, just assume stick to one convention.
Okay.
Okay, and here it should not be confusion velocity. There I have to choose the direction.
So it's going
uh,
down
uh,
and then like over the flat
Hold
surface and
on.
then
So let me choose this direction only. This is positive. So the first half, the velocity will be negative. So initially the velocity will be less or more, 0, right?
Yeah.
And then the velocity will keep on increasing
Wait, why is it increasing?
because it's going down, right? Going down, and it's along the direction of the pull. See,
Oh,
when you forget simply when even when you drop a ball from a height, when you're dropping it, the initial velocity is 0. As it reaches the ground, it will
it
keep on
gets
increasing, right?
faster. It gets
Because the
faster.
gravity is constantly pulling it.
Yeah.
So here also, it's pulling, gravity component is pulling it around the inclined plane.
Okay.
So as it keeps pulling, it will keep on increasing.
Getting
Velocity will keep on
faster.
increasing.
Okay. And then it gets to that, like, it's a straight line after that.
Okay, and then we'll continue with the same velocity up to T2, and after that the velocity will keep on decreasing until it becomes 0. If we take this height and height, this, if I assume that this height is h and this height is also h, then it'll go and stop here because that's how it
Okay.
started. That's how it started, right? The one which started the height h will go up to height h on the other side only.
Okay. So shouldn't it be like above the t-axis?
That depends on the convention. Velocity is see here I have used this direction. Other way also fine. Both are valid.
Okay.
I have chosen this above as positive, upward direction, and velocity is downwards, right?
Yeah.
Here also velocity. Here the velocity is upward. No, velocity is upward, but it is decreasing.
Mm-hmm.
Why am I getting so confused with the signature? Right. Okay, let's go to XT plot and then come back to this one. Maybe that way sign will become clear.
I'm not, I'm the worst with position over time. So if it's going down, isn't it a U?
Initially, x value is what? X naught is how much?
0? So it's starting at 0.
Oh, this is x naught. There is no y here. It's only x.
Yeah. Yeah, it's not a 0. It's sub-0, 0.
So this is 1 point, right? And
Yeah.
then x keeps on increasing, and then
Wait, why is it increasing? I thought it's decreasing because it's rolling down the ramp.
no, that is y. This x
Oh,
is this horizontal distance, not
this
the
is,
vertical.
but this doesn't talk about horizontal or vertical.
See, here it is 0. Here it is 25, right?
Mm-hmm.
How can it become 25? And here it is again becoming 50.
Okay.
So it is x only. X is this direction, and this is the origin of x.
Okay. And then it goes from 25 and then it's constant.
Yeah. So x is going to
Remain the same. And then it's gonna go all the way up to 50.
this is t1. After that, x is increasing linearly.
Yeah.
After that, x is increasing. See, this part is a straight line
Okay.
between t1 and t2, and this is a parabola, and this is also a parabola.
Mm-hmm.
Okay. And what is the difference between this parabola and this parabola?
One is going downwards and the other is, one has a maximum and the other has a minimum.
I have drawn the other way around. It's wrong. The downward parabola God. This parabola should be like this, and this parabola should be like this. The bottom parabola is like U, and the above one is inverted U.
Mm-hmm.
So how do you understand that one?
Because it stops at 50.
See, the slope here, okay, and the slope here, is it increasing or decreasing?
Increasing.
That means velocity is increasing, right?
Mm-hmm.
That's what is happening here. Initially, the velocity is 0, and then velocity keeps on increasing.
Yeah.
Okay, and here the velocity is this much, and the velocity has decreased, right?
Yes.
Okay, that's what is happening. Here the velocity will be maximum after you keep on decreasing.
Wait. Why at the end is the velocity decreasing?
It's going up, right? When you go up the hill, the velocity will decrease.
Okay.
When you're coming down, the gravity will pull it. When you're going up, again the gravity will pull it down. So the velocity will keep on decreasing.
Okay.
When you're coming down, the direction of velocity is same as the direction of the acceleration.
Okay.
The acceleration will help it keep increasing still further. While going up, the acceleration is opposite, right, to the motion.
Yes.
So we'll try to pull it down. So the speed will keep on decreasing.
Okay.
Okay. So according to this convention, here the velocity is positive, right?
Yes.
So it's better to draw it above. These two are straight lines. All three are straight lines, but this is a horizontal line in between.
Mm-hmm.
So yeah. So this slope will be g sine theta.
Okay.
The slope is acceleration, right? This is g sine beta. This slope. Here the slope is 0 in the middle. Okay. The mistake I made is the velocity. Uh, this is x component of velocity, not no. No, this is y component of velocity. Yes. So this is velocity along the line of motion.
Yes.
Right. Okay. The mistake here is positive direction is not this one.
Okay.
The positive direction is actually a curve.
Okay.
This is the positive direction.
Okay.
Okay. So don't get too much confused with it. So basically, velocity is along this direction only. So that's why it's always positive.
Mm-hmm.
Because here we are not analyzing x motion, y motion. Here we are analyzing the velocity along the plane. But the first
Okay.
one is how the x is changing along this time, because time is only changing along this line only. Time will keep on
Yeah.
increasing along this line.
Mm-hmm. Okay.
Right. Okay, the first thing, acceleration, you can fix the sign of the acceleration by whether the velocity is increasing or decreasing. Don't think of the sign, just look at the magnitude of the velocity. It keeps on increasing, right, the first half. So
Yeah.
that's why it's positive. In the third part, its velocity is decreasing, the speed is decreasing. So that's why the acceleration is negative.
Mm-hmm.
So from there, we can get the acceleration velocity as this one. And velocity is always positive because along this line.
Mm-hmm.
And also we have to get this positive slope, right? So it should be like this only. What is below means the slope will be negative.
Mm-hmm.
Okay, only if it is above the slope will be positive. Okay, revise it after the session.
Okay.
What about 3?
So my acceleration is gonna be a straight line.
Now, what does this arrow mark indicate?
The arrows.
Yeah, the length of the arrow. Is it the velocity? If the length is more, length more means the velocity is more, is it? See, the A part, since the velocity of the length of the arrow is same, I assume that the velocity is same.
Mm-hmm.
Vector, when you draw a vector, the length of the arrow you're drawing, that's corresponding to the magnitude of the vector. So the length of the arrow is same, then the
Mm-hmm.
magnitude of the velocity magnitude of the vector is not changing.
Mm-hmm.
I'm assuming this is velocity. Okay. So have they give the answer key?
Yeah, there is an answer key for all of the problems.
Yeah. So I'll just try. So the first one, A should, the velocity is constant, right? So
Yeah, so
this,
it's just a straight line.
so this should be
Okay.
A, and B, the velocity is constantly increasing, and we have
So
to
it should
see
be a
how
straight line up.
it's non-linear.
It's non-linear.
Velocity
Why?
is linear means it should increase. That I have to check.
At a constant rate.
No, see from here, if it is linear means here will be 2 times, here will be 3 times. No.
I think it's linear. We haven't talked about like non-linear much.
Okay, yeah, we are studying only constant acceleration, right? So if the acceleration is constant, then velocity should increase linearly.
So it's, yeah. And then C, it's
Okay.
it's getting smaller. So it's going downwards. But it's starting from 0 to negative.
Initially, the value is negative. After it keeps on increasing, it's becoming more and more negative, right?
Yeah. And then the last one, D, it's starting off like positive, but it's going negative.
No, no. Okay. This is the sequence.
Mm-hmm.
So it's starting from a larger value of x.
Mm-hmm.
So the uh, velocity is large, and then it keeps on decreasing,
Mm-hmm.
and then reaches minimum, and then it increases. So it should be like this point corresponds to this turning point. Okay. Can you check the answer key?
Yeah, 1 second. Everything's right except for D. D starts from a negative value and moves upwards in a straight line.
Hmm. See here, yeah.
Because,
Here, this is actually a displacement curve.
yeah.
Velocity is always straight line because you're using constant acceleration.
Mhm.
So D is negative. So this
I
is
think the acceleration graphs should be easy.
no, because here, yeah, the first one acceleration is 0.
Yeah. And then the second one, it's going to start from a small value and then be
No,
constant.
see, we are studying only constant acceleration motion, right? So this B case, velocity is increasing, so acceleration is positive.
Yeah. C is going to be negative.
That's because the
The
uh,
velocity is negative.
velocity is becoming more and more negative.
And then
No,
D is going to be positive.
the velocity is becoming more and more negative, right? So it's as if it's decreasing.
Yeah.
So that's why its acceleration is negative.
Yeah, I get that. I think D is going to be positive.
Yeah, because the velocity is uh, it's going to be negative. See, the velocity is decreasing, right?
Mm-hmm.
This is a time sequence.
Okay.
Velocity is decreasing and then increasing. So acceleration is always in this direction. It's
Okay.
unidirection. Whether it's positive or negative, we have to see. It's I assume it's negative, but according to this thing, it should be positive.
Yeah, because if you were to write numbers in.
Check the key.
Yes, that's right.
That's becoming clear from this velocity time graph because velocity time graph D part initially the velocity is in the opposite direction, right? So negative. So it starts from negative and then goes on increasing,
Mm-hmm.
becomes 0 and then increases. So the slope of this thing is positive. So acceleration corresponding B should be positive.
Mm-hmm.
So X A, so X is increasing linearly. Initially X is 0, right?
Yes.
B velocity is increasing. So this is B and then C.
C is going to be going down. Like, but not below the t-axis.
Yeah, you can truncate it. Just check the key ABC is fine.
Yeah.
Okay, and how see uh, B and C, it's either U or inverted U, right? So how do you
Mhm.
decide whether it's U or inverted U?
I think it's a U
See,
because it's going down and then it's going back
the,
up.
the difference is slope. The slope here is like this much and the slope here is this much. So what is happening to the slope?
It's getting bigger.
So B, the slope is becoming bigger because the speed is becoming bigger, right?
Mm-hmm.
And here the slope is speed. slope of xt curve is velocity, right?
Mm-hmm.
So since the slope is increasing, the velocity is also increasing. So this is correct then. I mean, whatever we drew for P is correct. In the C case, initially the slope is less, after the slope keeps increasing, right?
Mm-hmm.
That's what is happening because C, yes, this is a time sequence. Uh, Time sequence. Yes, this is a bit confusing only. X is increasing. Uh, is this key correct? C is
Yes.
okay. See, whenever they give a direction like this, the time sequence is like this.
Mm-hmm.
It starts from here.
Okay.
So this is the time sequence. Okay. So initially the velocity is more, and then velocity keeps on decreasing. So that's why it's going like this. Velocity is less. Oh my God. No, then this is not the time sequence. Then this is the time sequence is this way only. Okay, initially the velocity is small, but it's negative. Here the slope is negative.
Yeah.
Negative slope
Yeah.
means greater than 90 degrees. Slope will be between 0 to 180 degrees. Between 0 to 90
Mm-hmm.
degrees, the slope is positive, and 90 to 180 degrees, the slope is negative.
Okay.
Okay, because here you can see it's going down. So the slope is going down, so it's a negative slope. Here the slope is going up, so it's a positive slope.
Mm-hmm.
So the velocity is increasing. So in both the cases, the velocity is increasing, but only the sign is different. Here also the velocity is increasing.
Okay.
Here also the velocity is increasing, but the velocity direction is different.
Okay.
So the time sequence is this way only.
Yes.
Uh, Here in this case, then you have goofed it up because here the time sequence has to be this way only. We can assume this, let us say, otherwise the answer will be opposite. So here the velocity is initially large and it keeps on decreasing.
Okay.
So initially the velocity is large, right? So it should be, and it's negative. Check the key.
It's the other way around. Like it's a U.
Yeah. Then it should be downward. Okay, the only difference is whether it's positive or negative.
Mm-hmm.
Uh, is it like this?
Yes.
Yeah, it is matching with this. Here the slope is negative,
Mm-hmm.
and that's what is matching with this part. After that, the slope is become positive.
Mm-hmm. Mm-hmm.
Right? If it was the other way around, it will be other way around. If it is inverted,
Okay.
then for first half the slope will be positive, the second half the slope will be negative.
Oh, okay.
I hope they will not ask this question in the exam because this is a bit confusing. This just for learning part. It's okay.
Yeah.
Today is what, Saturday, right?
Yeah.
Okay.
I got -2 meters per second squared.
Check the key.
Yes.
See, acceleration delta y by delta t.
Mm-hmm.
You are given vt1 as 11 and then vt1 plus 3. T1 is some time. After the 3 seconds, it becomes 5.
Mm-hmm.
Okay, so acceleration delta y by delta t. So 5 minus 11 divided by 3 because 5 is the final, this is the
Mm-hmm.
initial divided by the time. Delta is final velocity minus initial velocity,
Okay.
not the other way around. So it should be minus 2 exactly
Mm-hmm.
rather than plus 2. Oh, what does the key give? Key does it give a sign?
They did it. I did it as V equals AT plus V sub 0.
Yeah. So
Because that's the way they want us to do it.
yeah, and velocity is decreasing, right?
Mm-hmm.
So acceleration will return to be minus 2.
Yeah.
Okay. Fifth one,
I didn't do this one. Um,
just try now.
the fourth one?
Fifth. Fourth is done, no?
Yeah, I'm saying the fourth graph.
Which of the following graphs do not describe the motion of a liquid in the previous question?
The fourth one?
Uh, this one. No,
Is it
acceleration is constant,
positive?
no?
Yeah, but it's positive.
Uh,
Our acceleration was negative. So it would be the first one is right, but the fourth one isn't.
what about this one? See,
I think that's right.
so that depends on the direction of what you choose. See, the prominent thing is the speed is decreasing, right, from 11 to 5.
Mm-hmm.
So
Oh,
this,
so it should be it. Okay, yeah.
so this one is wrong.
Okay.
This should be 11 and this should be 5. That's not matching, right? So
Mm-hmm.
check the key. 2 is the odd one out.
Yeah, 2 and 4.
More than one correct, is it?
Yeah.
Fourth one, acceleration is constant. That is fine. Uh,
It's
yeah.
positive, not negative too.
See, acceleration is negative in the sense speed, velocity is decreasing, speed is decreasing, right?
Mm-hmm.
Speed is decreasing when there is a deceleration.
Mm-hmm.
So that's why positive acceleration is also not correct.
Okay. I'm gonna try this one.
Yeah. Let's draw the figure.
Yes.
Is it a 1D motion or 2D motion?
1.
Okay. Got it?
Oh, 1 second. I got 0.094 meters per second squared.
Check the answer.
Okay. They got 94,000 meters per second squared.
Yeah, what is the mistake?
I don't know. I had the exact same equation.
Acceleration is delta V by delta t, right?
Yeah.
What is delta V?
Negative 43.
Delta V.
Oh, so I would do 51 minus 43.
Yeah.
94. Yeah, you get the same thing.
What's your answer?
0.094.
I got 94 into 10,000 into 1000, 94,000.
Yeah, but why are you multiplying it by positive 3 instead of negative?
Don't,
Oh, I see.
don't skip the steps.
Okay. Okay.
This diagram is clear, figure is clear.
Yeah.
Left is north, right is south. So initially it's moving towards south, 43 meters. And after hitting, it will change the direction, 51. And this changing velocity is happening in delta t of 10 raised to minus 3.
Mm-hmm.
So actually delta will be delta t. I'm choosing the right direction as positive. So the initial velocity is minus 43. Sorry, initial velocity is plus 43. Final velocity is minus 51. So final minus initial, so minus 51 minus 43 divided by, so minus 94 into 10 to 3. With the direction of right azimuth is positive. Clear now?
Yes.
7.
D is not possible.
What about A?
It could be negative 9.8 meters per second squared.
How can the velocity be 0?
During free fall?
Yeah, so you can give an example. So this is an example of a VT curve, right? At time t1, the velocity is 0, but the acceleration is not.
Yeah,
Okay, and what about B?
it's true.
You have to give an example. So object is moving towards north and acceleration is northward. So this is the north direction, and at time t1 let it be here. At time later time t2 will be here, and velocity at t1 is small vector, and velocity v2 are denoted by large vector. So that means v2 is greater than v1. So the object is moving towards north and accelerate north. So this is possible.
Okay.
So I represent by a diagram, right? An object is moving towards north but accelerates southwards. Is it possible?
Yes. It'd be moving north and speeding up.
So here the v2 vector is smaller than the v1 vector.
Yeah, D is not possible.
Yeah, first finish C. C, the difference between B and C is here V2 is smaller than V1.
Mm-hmm.
In B, it's other way around. V2 is increasing. V2 is more than V1. Okay, object travels with constant velocity and changing acceleration. So V is constant means acceleration is d by dt of V.
Mm-hmm.
So V is constant means it is not changing with time, so it is zero.
Okay.
The acceleration has to be zero.
Okay.
So zero means it's a constant acceleration is zero acceleration. So it's not a changing acceleration.
Okay.
And a vector constant means both the magnitude and the direction are constants.
Okay.
Vector has got both direction and magnitude, right?
Yeah.
So when a vector is constant means both the direction and the magnitude both are constants.
Okay.
Okay, E.
It's true.
Yeah, here the velocity is changing and the acceleration is constant. Acceleration constant means a straight line.
Yeah.
Acceleration constant is slope of a VT curve.
I got negative 9.4 meters per second.
Which one?
Number 8. I did some of the math problems first because I knew that those were the
Yeah.
most important ones for me.
Okay, what is the answer key?
Negative 9.4 meters per second.
Is it correct or not?
Yes.
Ah.
9. An object moving along a straight line has decreasing speed. Identify which one of the following statements concerning the object's acceleration must be true. So it's moving in a straight line, but it has a decreasing speed. Isn't it constant?
Draw the diagram first.
Okay. A and T.
No. Okay, you just draw the diagram of the first statement. Okay, you just try.
Object has a positive acceleration. Okay.
So it's moving straight. So first I'll draw the line in which it's moving. Decreasing speed, right? So I'll denote the velocity vector. Here it is like this. Here it is decreasing, and here it is still decreasing. Okay, so the object has got positive acceleration. Whenever speed is decreasing means A is negative. Okay, direction of acceleration is same as the direction of if the direction is same, the velocity will keep on increasing. So this is not true.
Okay.
The direction of acceleration is opposite to the direction of velocity. This is true. Acceleration is nothing but a force because force and acceleration are related by F equal to m into A. So when the velocity decreases, there is a force which is against the velocity. Force against the velocity is same as acceleration against the velocity.
Okay.
So the direction of acceleration is the direction opposite to the velocity. So check the key.
It's right.
Yeah. See, whenever acceleration is there, then the speed will increase.
Okay.
So here the speed is decreasing, right? So acceleration has to be negative.
Okay.
Okay. And when the speed is decreasing means there is a force which is against the velocity.
Oh.
Okay. And force is same as acceleration because F equal to m into A. You know this relation, right? F equal to m into A.
Yes.
So in that, if F is a vector, A is a vector, M is a scalar. So the direction of force and acceleration are same.
Okay.
F is aiming to E, right? And A is a vector, so mass is always positive. So the
Okay.
direction of A and direction of F are same.
Okay.
Okay, so when velocity is decreasing, means there is a force which is opposing that velocity.
Okay.
So force velocity direction is opposite to the velocity direction, and direction of force is same as the direction of acceleration.
Okay.
Okay, so acceleration should be opposite to the velocity.
Okay.
Uh,
Yeah, I got this
okay,
one.
you check the answer key.
Yeah.
Is it
Yeah, I got
matching?
it.
Okay. What about 11?
Um.
Okay, shall we take a break now?
Yes.
Uh, uh, I'll end this meeting now and I'll give you WhatsApp message. You just keep trying the problems.
Mm-hmm.
I'll give you a WhatsApp message after half an hour
Okay.
and then just check what you're doing.
Okay.
Okay, we'll end now.
Okay. Do you want to meet tonight?
Yeah. I'll just
I'm free till
message.
1.
I'll message you after half an hour.
Mm-hmm.
You just keep trying.
Okay.
Okay, then bye.